Hello students, we are continuing practice set 1.3. Question number 5 given. In trapezium PQRS, side PQ is parallel to side SR. AR is equal to 5AP, AS is equal to 5AQ. Then prove that SR is 5 times of PQ. So students, if we look at these sides which are given, these sides are the sides of these two triangles, triangle PAQ and triangle RAS. If we show these two triangles similar by using a particular test, we can take their sides in proportion, and that proportion will take us to the answer. So how to show these two triangles similar? Already the two angles of these two triangles, which is the opposite angle, is congruent. The second angle is alternate angle. Means if we take these two sides parallel and their transversal PR, then the alternate angles can be shown congruent, so that we can show these two triangles similar by double A test. So first, let us see PQ is parallel to side SR and PR is a transversal of these two parallel lines. So we can take these two angles, angle QPR congruent to angle SRP. Now the reason is alternate angles. So alternate angles are always congruent. That's why we have taken these two angles congruent. The names of these two angles can be written in a different way according to triangle wise. QPR can be named as angle QPA. That is, angle QPA is congruent to angle. The name of the angle SRP can also be written as angle SRA. Angle SRA. Give this number 1. Now consider the two triangles. In triangle PAQ and triangle RAS. First, angle PAQ is congruent to angle RAS. Now angle A is congruent with angle A. It means that they are opposite angles. The reason is opposite angles. Second angle of these two triangles, angle QPA, is congruent to angle SRA. And you can give reason here from 1. We have already shown these two angles are congruent because they are alternate angles. You can give the reason here from 1. Now when the angles, two angles of one triangle are congruent with the two angles, corresponding angles of another triangle, then the two triangles are similar. So we can write here triangle PAQ is similar to triangle RAS. And the reason for the similarity of these two triangles is double A test. Now once you shown the two triangles similar, you can take their sides in proportion. Let us write the proportionality here. If we take PQ, then the other side of triangle, corresponding side of another triangle is SR. So PQ upon SR is equal to PA upon AR is equal to QA upon AS. And the reason for this step is these are corresponding sides of similar triangles. Similar triangles, and these are the sides of these similar triangles. Now give this as equation number 2. Now we can use the information from the question. AR is equal to 5AP or AS is equal to 5AQ. You can use any one of these two informations. So let us write here, but AS is equal to 5AQ. Now if we put this value of AS in this equation number 2, the equation 2 becomes PQ upon SR is equal to PA upon AR is equal to QA upon the value of AS is 5AQ. Now here AQ will be cancelled, remains only 1 upon 5. So the next step will be PQ upon SR is equal to PA upon AR is equal to 1 upon 5, because AQ is cancelled and remains the numerator as 1 and upon 5. Now PA upon AR is also 1 upon 5. We can see there in a question AR is equal to 5AP, so it is also clear. Now we can omit this equality or this ratio, and we can write here PQ upon SR is equal to 1 upon 5 only. Now if we cross multiply these, then we get SR into 1 SR is equal to 5 into PQ means 5 PQ. In this way we get the proof for SR is 5 times of PQ. Let us see question number 6. In trapezium ABCD is a trapezium. Side AB is parallel to side DC. Diagonals AC and BD intersect each other in point O. If length of AB is equal to 20, DC is equal to 6, OB is equal to 15, then find OD. So students, if we look at these lengths, these are the sides of the two triangles, triangle COD and triangle AOB. So if we show these two triangles similar, we can take their sides in proportion, and that proportionality will help us to find the length of OD. For showing these two triangles similar, we have to use a particular test. So double A test will be very easy here to show these two triangles similar. The pair of opposite angles is already congruent here, and if we consider these two sides which are given parallel and AC as their transversal, then the two angles which are alternate angles can be shown congruent. So let us write first side AB is parallel to side DC and AC is their transversal. So alternate angles made by this transversal, angle DCA will be congruent to angle BAC, and reason for this is that alternate angles. So these angles are congruent because they are alternate angles. The names of these two angles can be written in a different way so that we can apply them in these two triangles. Angle DCA can also be read as angle DCO, congruent to angle BAC can also be read as angle BAO. So the measures of these angles are same, only the names are different, and give this as number 1. Now let us consider these two triangles. In triangle COD and triangle AOB. First, angle COD is congruent to angle AOB. These two angles are congruent. The reason for this is opposite angles. Now the second angle of these two triangles is angle DCO is congruent to angle BAO. And reason for this step is from 1. We have already shown these two angles are congruent from 1. Now when the two angles of one triangle are congruent with the corresponding two angles of another triangle, then the two triangles are similar. Triangle COD is similar to triangle AOB. So these two triangles are similar because of double A test. Now once we show these two triangles are similar, we can take their corresponding sides in proportion. So which sides to be taken here? If we take CD, the corresponding side will be AB of another triangle. So CD upon AB is equal to OD upon OB. Now the third ratio is no need to write here because the lengths of OC and OA are not given. We are also not finding out any one of these two segments OC or OA, so no need to write. But this proportion is because of the two triangles are similar and these are the corresponding sides of these two similar triangles. So corresponding sides of similar triangles is the reason for this step. Now let us put the values. CD means DC is given 6, AB is given 20, is equal to OD, we have to find it out, and OB is given 15. So if this 15 is shifted to the left side, we can write the step here 6 into 15 upon 20, and what remains on the right side is OD. So let us divide these two numbers first. Both are divisible by 5. 5 4s are 20, 5 3s are 15. Now these two numbers are again divisible by 2. 2 2s are 4, 2 3s are 6. What remains here? OD is equal to 3 into 3 is 9 upon 2. If this 9 is divided by 2, we get OD is equal to 2 4s are 8, remains 1. If point is taken here, 1 becomes 10 and 2 5s are 10. So this is the length of the OD, 4.5.